Hello and welcome to our robotics lab. Have you ever wondered how these robots, which work with incredible speed and precision in factories, actually operate? Today, let's understand the science behind them. Today, we will explore the amazing world of the FANUC ER4IA robot. This robotic system is primarily composed of three parts. The first is the mechanical unit, which is the actual arm of the robot. The second is the controller. This acts as the robot's brain, processing all instructions. And the third is the teach pendant, working like a remote control. It is what we use to program the robot. The real secret here lies in its capabilities. This robot moves across 6 axes, much like a human arm. It boasts a reach of up to 550 millimeters, can handle a payload of 4 kilograms, and has incredibly precise repeatability of plus or minus 0.01 millimeters. Now, before we move on to the practical phase, keep these 3 stations in mind. The pickup station, where objects are lifted, the assembly station, where they are put together, and the vision inspection station for quality checks. Come on, let's start the practical pick and place demonstration in the lab right now.
Hello everyone. So today we have a student with us who is going to perform a program on the robo. So today's program that we are going to do is we are going to do a program for pick and place of the robo. So let's start with the program. Take the teach pendant. So for the teach pendant, you remember that you have to turn it on and you have to release the emergency switch. Okay, it is all released and it is turned on. Remember that you have to hold the dead man switch and you have to reset all the faults.
Let me step in here. The dead man switch is your ultimate lifeline on the shop floor. Why must we hold it? It acts as a fail-safe. If an emergency occurs and you panic, faint or drop the pendant, the switch is released. This immediately cuts power to the robot's servo motors, stopping all movement. Never attempt to bypass this switch.
Okay, now once all the faults are reset, you create a new program. So go to select, okay, enter, and you create a new program of say 20 lines. Okay, so now you have all created a program. Let's start with teaching the robo. So move the robo, change the coordinates to jog, joint, okay, and let's start moving the robo. So what axis are you moving? You can just mention the axis. Take the axis, bring it down to this position. Okay. Take it in word. Change the coordinates to word. Keep the minimum speed. Okay. Keep the minimum speed and now you can bring the robo down. Make sure that you don't collide to any parts of the robo. Teach the point. Whenever you have to teach the points, you have to record the position. Take the precise angle and move. Do this down and do this a little up. Do this up, parallel. Bring this up so that it goes down in a straight line, linear. Take it in linear.
Attention students, notice the switch to linear coordinates. Why is this critical when approaching a part? In joint mode, the robot calculates the fastest path, which often results in the arm swinging in an arc. Near a workstation, that arc will cause a catastrophic collision. Linear mode forces the robot to move in a perfectly straight line, ensuring a safe approach.
Okay, now take this parallel so that it goes linear down. Yes, take it up, take it in a straight 90 degrees. Now you can bend the robo. Yes, take it down slowly. Teach this position. Move a little behind. Yes. See to that none of your parts of the robo are going to collide with the station. And do not put your hand inside, or do not put your head or something, or keep any objects over here or your phones, because it is very dangerous for the robo. Teach this position now. Yes, good. Decrease the speed. Yes. So now that we have bought our robo here, now we want our gripper. This is called as gripper. We want the gripper to clamp or declamp. Bringing the gripper together is called as clamping, and extending the gripper is called as declamping. So now what we need to do is we need to clamp the gripper before clamping. So what will happen if you don't give a weight? The robo will come down and just grip it. So what we need to do is, before this you need to give a 2 seconds of wait, so that the robo will come to this position, will wait here for 2 seconds and then clamp the job.
Let's talk about the physics here. Why add a wait timer before gripping? In industrial automation, we call this settling time. When a heavy robotic arm stops moving, it carries momentum and vibrates slightly. If you actuate the gripper instantly, the misalignment can scratch the workpiece or damage the gripper jaws. A 2-second wait ensures the arm is perfectly still.
Okay, so give wait. Go to select, give wait, give 2 seconds and enter. Okay, then go to IO, then go to RO and give the gripper clamp, say on. Now that it is declamped, you can see there is a gap between two grippers. So when it is going to clamp, it is going to come closer. Okay, see, it is going to clamp and it is going to declamp. This is declamp, this is clamp. Okay, now what we saw that when we are trying to grip this, our job is smaller, or say the diameter of this is different than the diameter of our job. So what usually students make mistake is that they don't realize the diameter of both the sides is different. Okay, so what you need to do is you need to either check it with the scale initially when you have to start, or you need to check it at this position, so that now that we have realized it that the job positions are different, we will correct it. Okay, let's declamp the gripper. Okay, now that we have declamped, take the robo to the initial position. Okay, increase the speed because we are in the safe space. So we will bring the robot to a safe position. Now that we see that there is a lot more of gap here, so it is in the safe position. So let's rotate our gripper to 180 degrees. So we have to rotate it upside down. Yes, go slow. Okay, now that we have rotated the gripper, we'll check again. Take the gripper down. Take the gripper down, be slow. Decrease the speed. Decrease the speed. Okay, now go down, get the gripper, check with the precision, because a small error here when you are doing will cause a greater harm for the robot. Take a top view so that there won't be any errors. Okay, if you see from this angle, I will feel that yeah, it is correct. If he sees from that angle, he'll feel correct. But try to get a bird's eye view so that it will be correct. Okay.
A vital lesson for any robotics programmer: beware of parallax error. Judging your alignment from a single side angle is highly deceptive. If you try to force a misaligned shaft into a bearing, you will crash the robot and overload the axis motors. Always verify your position from a bird's eye view or two different 90-degree angles before making contact.
Okay, now you can see. Okay, now here you can observe there is a good space between the base, good space to hold for the cylindrical part, like to this position it is having a good space, and to the base also it is having a good space. So this is the perfect position that we need to maintain. Now we can grip. Okay, you need to give weight, don't forget that as well. Give a weight and then put grip. How grip is selected? It is selected through robo. Okay, inputs of the robo. Okay, now that it is perfectly gripping, you can pick up the job. Give a weight. After gripping also you need to give a weight. So two places you need to give weight. One is when you bring the robot to this position, you need to give weight, then grip, then again weight, and then bring it to the top position, to the safe space. After giving weight, bring the robot up. Okay. So till here we understood how to teach the robot from first bring it down, give weight, grip, bring it up. Okay. Now we can place it. We'll program it to place in this position. Don't go too much inside. Decrease the speed and bring it slowly down in the linear. Wait, move little forward. You can come to this side and you can check. See, there is a gap over here. It is not aligning. So properly align it. Move forward. Bring it forward. Change the coordinates and bring it forward with y-axis. Yes. Okay. Okay, go slow, go slow. Yes, good. I think you will have to take little left. Bring it to this side, little bit. Check. Be slow at this position. Give a weight and open the gripper. When you release the deadman switch, you can hear the sound click. So that is what happens when you release deadman switch. Okay, so the whole programming that you are doing, you need to always keep your deadman switch in your hand. Okay, so declamp it. Yes, perfect. It's really a great job. Now give a weight and bring the rover back to a safe position. Give weight. Did you give weight? Okay. Now bring the robot up, straight, vertically up. You guys can see perfectly he has placed the shaft on the bearing. Now bring the rover back to its safe position. If you are getting faults, reset the fault. Okay. Yes, increase the speed and bring back to a safe position. Okay, now let's start with the automation. We'll check the robo in the auto mode. Okay, Ritikesh, you can start it. This is where we checked the gripper with the shaft. So we found that it is not perfect for our gripper, so we changed the gripper position. It is perfectly gripping. Now it is going to place it in the bearing. Yes, well done. Now it is back to its home position. Well done, Ritikesh. So now we saw the program for Robo Pick and Place program.